executive, Jerry. Bless you. On three, 1, 2, 3. So today we're moving on to box plots. So get that in your prayer model. And we're going to be looking at now not only, bless you, not only one set of data as we've been looking at from last week to now. I'm going to give you 2 sets of data. You'll see how we can use that to come up with summarizing conclusions and getting answers to whatever the questions they're asking in regards to the problem presented. So box plots, what are they? In your prayer model, write this down. Box plot shows how the value in the data set are distributed using the minimum, first quartile, the median, third quartile, and maximum. Now, the median, we already know that that's Q2, right?
Yes, Mr. Q.
And the first quartile is Q1, and the third quartile is Q3. So the only thing that's different here is that we're including the minimum, which is our least value, and the maximum, which is our greatest value. So write this example down after you copy the definition. Copy that, and then I'll go over it once you're done. Give you a minute. Yep. All right. So let's talk about what we have so far. It says box plot. Shows how values in a data set are distributed using the minimum, the maximum, Q1, Q2, and Q3. Let's see. Now, like I always do with a concept presented, we look first at the terms that they give us. So look at the 2 words that they give us: box, plot. Let's start with the last word, plot. Do we know what that means? Yeah, to plot points. Do we have points plotted on our graph? Yes, here they are. 1, 2, 3, 4, 5. They have plotted points. And why do they call it box plot? Because with 3 of those points, they make a box. Straightforward. Now, some of you were introduced to this, and they called it what? Box and whiskers. You guys remember that? Some of you? Now, the reason they call it box and whiskers is because here we have a box created by Q1, Q2, Q3, and then they draw a whisker from the Q1 to the minimum and Q3 to the maximum. So we have whiskers on the sides and the box. Okay? So just to be clear as to what we're looking at, once again, first quartile, this one is Q1. The median is Q2. And the third quartile is Q3. And those 3 are needed to create the box. Let me show you a non-example. Non-example. Copy that. And as you're copying it, start thinking, what are the components that are missing from that one as to why it's not a box plot? Copy that. Then I'll ask someone to share. Go. All right, let's see. So tell your neighbor why this one is not a box plot. Talk it over your neighbor. What pieces are missing? Okay, I was kind of overhearing some of you. This one does have a minimum and does have a maximum. But we're still missing stuff. Nate, what are we missing? First quartile, so Q1. And the second quartile. What else are we missing? Mia? Yeah, the median is Q2. Q3. And what did we need to create our box? Q1, Q2, and Q3. That's what made the box over here. Since we don't have it here, therefore we don't have a box. Therefore, this does have a name. This non-example. It's not a box plot. Tell your neighbor the name of that data. Everyone. That is correct. This is a dot plot. So, let's hashtag this picture that you're going to send out on whatever, Instagram, WhatsApp. Hashtag what? Leslie. C. Bam. Ooh, Mia. Quartiles. What else? Kylene. Hashtag no dot plots. No dot plots. Whoa. Plots. And one last one. Let's see. Who hasn't gone in a while? Oh, Melanie, go. Thank you, Maria. Let's see, we have a box, yes. We have quartiles, yes. No dot plots, okay. What are we missing that you can label this when you send it out? Hashtag whiskers. Yeah, when you were like fading out, I said when this one we have a box and then we have a minimum connected to the first quartile and the maximum connected to the third quartile to make two whiskers. Yes. So we got that? Yes.
Yes, Mr. Q.
All right, good. Let's move on. Copy these steps. It's only 7. Copy that. I'll give you some time. Go. All right, so as you can tell from the steps here, step 1 is like with any other data, you organize it from least to greatest. Then you need to identify Q1, Q2, and Q3. But you always start with a median, which is Q2, so you can start splitting your data in half. From there, you identify minimum and maximum. You plot all the 5 points, make a box and whisker. And then you summarize data by answering any questions. Everybody got it?
Yes, Mr. Q.
All right, good. So writing utensils down, look up to the screen. I'm going to go ahead and go over this example. You don't have to copy, just pay attention. I'll give you time to go over another one for yourself. Here you go. So let's follow the steps. What is step 1 once I give you a set of data like that? From least to greatest. So therefore, look at the problem though. It says the number of runs scored by a softball team in 20 games are given. That means I have how many numbers in front of me? 20. So I'm going to start with the smallest one, which is, very good, 2. And then from there, 3, 3, 3, 1, 2, 3. From there I go to 4, 1, 2, 3. Oh, sorry. So I go 4, 4, 4. From there I go to 5. From there I go to set. There's no 6, so it's 7, 7, 8, 8, 9, 9, 10, 10. So I go 7, 7, 8, 8, 9, 9, 10, 10. Then I got 11, 12, 12, and 14. All right. So, really quick, they said to find the median. So how many numbers do we have? 20. So I need to count 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the median should be right after 10. Is there a median? No. That means what do I need to do, everyone? Add 7 plus 8, that's 15, divided by 2, it's 7.5. That's our Q2. All right. So now that splitted the data in the lower and the upper half. I'm going to go to the lower half. I'm going to find the median again, but I'm going to label it Q1. So let's see. How many numbers do I have here? 10. You need to count 1, 2, 3, 4, 5. The median should be here. There is none. So what is 4 plus 4? 8 divided by 2 is 4. So that is Q1. Okay. I need to do the same to the upper data. 1, 2, 3, 4, 5. There's nothing here. So 10 plus 10 is 20. Divided by 2 is 10. That's Q3. Identify the minimum, which is 2, and the maximum, which is 14. Now that I have my 5 data that I need in order to plot onto the number line, I need to scale the number line according to the numbers that I have here. Let's see. Going from 2 to 14, what should I scale this? By what? By 2s. I'm going to start at 0, 2, 4, 6, 8, 10, 12, 14. All right. So what's my minimum? 2. But watch. Instead of plotting it on the line, I'm going to plot it right a little bit above the line. What is my Q1? 4. So that goes here. Well, I'm going to switch colors to black. Right there. What is Q2? 7.5. So 6 is here. 7 is here. So 7.5 is about right there. There it is. And Q3 is 10. And my maximum is 14. So which ones do we need to create the box? Q1, I'm going to label it Q1, Q2, and Q3. Those are the 3 that I need. I draw a line through the point like so, all 3 of them, and then connect them, and it creates a box. But we're still missing the minimum. We need to connect the minimum to Q1 and the maximum to Q3. And I'm going to label this 2. This is 14. And that's how you create a box plot. Fairly simple? Yeah, because we've been doing this since last week, haven't we? Q1, Q2, Q3. The only thing that we added today is what? The minimum and the maximum. All right. So with that said, you go and do that the same. Copy that example B. Copy the problem. It says, the shoe size of 12 members of the basketball team are given. Use the data to make a box plot. Okay, copy that. And once you're done, send me your box plot. I'll forward the screen a little bit. Yep. There's the answer for example 1B. So notice that the minimum is 8, the maximum is 15. It's a little bit out of the picture, but I can see it. Q1, it looks like it's 10. Q2, 11. Q3 is in between 12 and 13, which is 12.5. You got it? Fairly simple?
Yes, Mr. Q.
All right, good. So now let me show you. So what we just did, we just plotted and created a box plot for one set of data. Tonight, they're going to ask you to do it for 2 sets of data, but using the same number line. So imagine what you did there, but now you're going to do a box plot above that other box plot. So you need a little bit more space. Does that make sense? So now let me show you what it's going to look like on the home plate. Let me forward this. Give me a second. All right, so look at example 2A. You're just paying attention. Look up to the screen. I'm going to go over this one really quick. Sorry? Yeah. All right, so the problem at hand, it says, the box plot show the ticket sales in millions of dollars for the top 25 movies of 2000 and 2007. So how many different years are they comparing? 2 years, right? 2000 and 2007. So once they got the data, they plotted 2 boxes on the same number line. Notice it's only 1 number line and 2 box plots. Does that make sense? Okay, so check this out. Before we start answering questions, we need to take this data and label each component in order for us to compare our data from one to the other. So watch, I'm going to zoom in. And once again, we're talking about this in millions of dollars, so you can have that as perspective. I'm going to start with the year 2000. Look up. Look at minimum. What would be our minimum for year 2000, Molly? 80 million. So here's 75, here's 100, in between, yeah, it's about 80. So what would be Q1, Armando? Well, let's see. This is 125 over here. This is about halfway, so how much would that be? 115. How about Q2? Abraham. 125. How about Q3? Kiana, C. This is 150. This is 200, so halfway there is 175. And our maximum, I'm going to do that, so it's 250. This is 275, so I'm thinking about what? 265? All right, so now that we're done with that data, I go to the next one. My minimum, let's see, this is, it looks like it's between these two, isn't it? So what's in between 115 and 125? 120. Q1 is a little bit above 125, so I'm going to say 130. Q2 is right below this one, so what would I label that? 170. Q3 is right below 250, so I'm going to label that 240. And the maximum is right below 350, but above 325, so I'm going to label that what? I'm going to do 335, yes? Now that we have that data, let's answer some of the questions. Here it goes. It says, which data has a greater median? Tell your neighbor which one has a greater median. Everyone. 2007. What is the median for 2007? 170 million. It's in millions. It says, which data has a greater quartile range? So let me refresh your memory. If I was to ask you to find the IQR for each of these, find it, please, and then compare the data to see which one has the greatest one. Okay? IQR for the year 2000. Who can give me that? Let's see. Tony. Help him out, Letty. Okay. Okay, Gabriel. Okay, for those that forgot, it's Q3 minus Q1. That's how we find the interquartile rate. So therefore, this is 60. 175 minus 115. Therefore, what is the IQR for 2007? 110, because it's 240 minus 130, so that's 110. So therefore, the one with the greatest IQR is 2007. And what was the IQR for 2007? 110 million. Now, how does that help us? That usually helps by saying, well, how much did it grow from the first quartile to the third quartile? So which one had the most growth? 2007. Does that make sense? All right, let's go to the next question. What year had the highest earnings? Well, by the looks of it, 2007. And tell your neighbor how much more did it grow? How much more did it grow? Yeah. Oh, 2007. Yeah, I did that on purpose. The other one too? Okay. There you go. All right, about how much higher was the other? Let's see, Emmanuel. Allie. What? Okay, the maximum was 335, and the other one is 265. So therefore, Omari, 70 million more. So 70 million more tickets were sold for 2007 than in 2000. And that's how you compare data once you set it into two. Okay? All right, I'm going to send you a screen. You're going to do this one by yourself, and you can answer it on the screen. Example 2B. And there it is. Answer that and send it in. Ready, go. While you work on that, just a reminder, our home plate for tonight is on page 459. Okay, there is tutoring today. If I don't see you, your home plate. See you guys tomorrow. Bye.